Okay, our second symmetry is symmetry about the x-axis. So we say that a graph is symmetric about the x-axis if for every point xy on the graph, the point x negative y is also on the graph. Okay, so let's take a look. Okay, so here we have a graph. We see that this graph, the point 4, 2 is on the graph, and we also notice that the point 4, negative 2 is on the graph, right? And so we can say that this graph is symmetric about the x-axis. Notice that I can pick another point if I wanted, and I can pick this point over here. That's about 2.01, 1.42, and if I look down here, I would have 2.01. Just move it a little. 2.01, negative 1.42 is also on the graph. Okay. Also, like I mentioned, if I were to fold this paper about the x-axis, then the graph would fall on itself. So how do I check for symmetry about the x-axis? So checking for symmetry about the x-axis. Okay. So what we do here is we replace y by negative y. Okay. And if the resulting equation, so if the resulting equation is equivalent to the original equation, we say that the graph is symmetric about the x-axis. So let's try an example. So consider the function y squared minus 3 equals x. Okay, so now what I want to do is I want to replace y by negative y. So if I do that, I get quantity negative y squared. Remember, the negative is also in the parentheses because I'm replacing the entire variable y by negative y. Okay, and then minus 3 equals x. And again, negative y squared is just y squared. Minus 3 equals x. And I notice that the equation that I have and the equation I began with are the same. And so we can say that this graph is symmetric with respect to the x-axis.